In this video, we are going to talk about the mesh analysis and normal mesh, especially the super mesh, and how to solve the equations which related to mesh analysis. There are two types of mesh analysis. The first one is when a current source exists only in one mesh, and then when a current source exists between two meshes, called super mesh. For example, when a current source exists in only one mesh, like I draw that. This is 4 amps current source, and here is a voltage source 4 volt, and then there is a dependent current source. So let's see, there are two current sources, and the two current sources exist only in one mesh. This current source belongs to this mesh. This current source belongs to this mesh. So like that, this is the first category. That's when a current source exists in only one mesh. This is called normal mesh. So this is not called a super mesh. This is normal mesh. What is super mesh? When a current source exists between two meshes. Let I draw that. This is a current source 2 amps, and it placed between two meshes. This is called super mesh, and this is super mesh. And we take an example. This is a normal mesh example. Find the I1, I2, I3. Find I1, I2, I3 using mesh analysis. So we are going to find these three currents using mesh analysis. So for mesh analysis, what we gonna start with, we need to put the mesh current. I put in here this mesh I1 and this mesh I2. You're gonna like what I3 or I4, IE, IV, what you that's randomly you can put. Then I write this. Apply KVL, Kirchhoff's voltage law, to mesh 1. What is KVL? KVL means the whole voltage drop across a mesh is equal to 0. That's Kirchhoff's voltage law. So I start with here to here, here to here, here to here, here to here. Then I start with here to here. So this is minus 15 voltage plus minus 15 voltage plus here. We don't know the voltage, but we know the current I1 in this mesh and the resistance. So V is equal to IR. So for voltage, instead of voltage, I put current into resistor. So the current I1, resistor 5 I1, plus in here 10, this mesh I1 and this mesh I2. So I1 opposite I2, I1 minus I2, plus in here there is a voltage drop 10 volt is equal to the full mesh is equal to 0. So this is the first equation, we get it from here, and then apply KVL to mesh 2 in here. So let's start with here to here, here to here, here to here, here to here. So when I start with here, there is minus 10 voltage plus 10 into resistor 10. Current is this direction, I2 minus I1, plus here 6 into I2 plus here 4 into I2 is equal to 0. That's the second equation. When you solve these two, I1 and is equal to 1 ampere and I2 is equal to 1 ampere. We can find from there I1 is equal to I1, I2 is equal to I2, I3 is equal to I1 minus I2. We can easily solve this 1 amp, and here is 0. So that's the answer for this. Let's take another example, and here is the super mesh. How to find the super mesh? When a current source placed between two meshes when a current source placed between two meshes. So this also a super mesh, this also a super mesh. So these are super meshes. So from here, how do we solve it? Find I naught. So first I'm going to put the current mesh currents. So I put in here I1 and I2 and I3. So we can before that we can find that 3 I naught is equal to I2 minus I3. That's from our picture. And here also 5 amps is equal to, in here 5 amps is equal to I2 minus I1. Here is the first star, here is the second star, and we have 1 2 3 4 unknowns. We need 4 equations, so 2 equations are coming. We need to put apply KVL to supermesh. Supermesh is here, so I'm starting from here to here, here, then it's the finishing end. So when I start from here, 6 into I2 plus 2 into I1 plus here 4 into I3 plus here 8 into I3. So I need to put in this mesh, I put I4. The direction is not problem when you have wrong direction and you need to get the negative sign for this. 8I3 minus I4 is equal to 0. So this is our another equation. I need to put apply for this mesh also. Apply KVL to mesh, not super mesh. This is super mesh, this is normal mesh. So 2I4 plus 10 volts plus 8I4 minus I3, because I am going this direction, so I4 minus I3 is equal to 0. This is the second equation. So those are the equations. When you solve these 4 equations, we find I1 is equal to minus 2.5 amps and I2 is equal to minus 2.5 amps and I1 is equal to we don't need to find the I1, so I2 is equal to 2.5. Just I'm going to raise this. I2 is equal to 2.5 amps and I3 is equal to 3.9 amps and I4 is equal to 2.14 amps. So when we need to find the I naught here, I naught is equal to minus I4 from this. So I naught is equal to minus 2.14 amps. That's the answer. Thank you.